Well, I'm gonna be working on the thigh. This is like the orthopedic thigh drone. This has four sections, four separate parts. For each individual four separate shots should be rotary bearing, the propeller bearing, and the rotary housing, drum housing. Um, these will these will the materials as far as the thermoplastic will function. Will be powered by servo motors. So the servo motors will close the door in and out. These will be connected in a chain. All four of these parts will be where it will have rotary bearing. The thigh. This is the calf. This is the thigh. That's the shoe. I'm gonna also manipulate that in the metal that I have. Thick gauges and pieces of metal that I'm also going to be getting additional segments so I can replicate this into this metal. This metal is very thick. I think that it would be worthwhile using for this material, kind of like not bending deformation and replicating the single individual parts. So they'll be translated, but I'm still keeping the plastic. The plastic is necessary for the winding coil. So when I do add the coil winding, I'm going to apply them continually and just oval these entire parts, wrapping the entire segments in winding coil. So separate parts will be like a terminal. That will be a transformer, that will be a transformer, that will be a transformer, that will be a transformer. And these will have electromotors. So actually the electromotive that I'm going to use is solenoid type. To where the winding goes, energy goes down. This will assist with tubing, piping for fluids and moving fluids or gases downward. However, air force, as far as oxygen and neutrons, it also pushes that downward too. With thermomagnetohydrocaloric dynamics, also with I'm going to be adding, in addition to the thermomagnetohydrocaloric dynamics, I'm going to be adding the uh, two different forms, which is palletary effect, alongside when I add the winding coils. And for the tubes, the pipeline, I'm going to be using series of the palletary effect, but not the palletary modules. I'm going to be using quartz crystals and quartz crystal rings and nickel dium rings with piezo ceramic rings. The oscillation of the piezo ceramic rings will cause turbulence against and bending deformation of the quartz crystal. And the quartz crystal was obvious is pyroelectricity, and it could generate energy. I'm also going to be formulating the same kind of series of how can I say foils. So I'm gonna be wrapping these in foils. The direction I'm going to wrap the foils is in this direction, and how can I say it? A horizontal direction. And as far as the edge, all the edges I don't have to cut because it's like rectangle parts. And all I have to do is cut into the part right here. So even though it's in a foil direction, wrapping it in the coil, I have this part right here that's local to the ends that's still going to make the turns and complete the turns, as well as this is going to complete the turns, and side is going to complete the turns. However, these ends are going to be where the rotations of the coils, the scrolls, are going to be of the foil. We're making an ultracapacitor with cathode and anode foils localized with each other, separated by wax paper. So that's going to be used for my power supply. I'm also going to be adding pyrocrystals and nickel neodymium with also piezo buzzers. These buzzers will be modulated by ultrasonics. Ultrasonic reciprocation will generate energy instead of electrical energy to and auto recharge the ultracapacitor. Thus, I would have lithium coin batteries alongside within the system, just as I have it alongside within the system, coupled to the gate. However, along to the U brackets or arm. Thus, these coin batteries are 6 volts apiece. They're going to be able to recharge the coin batteries. The ultracapacitance will have enough power in it to be able to exert the energy. It will be modulated with a rectifier and an inverter to power down or power up anytime that is necessary. according to the circuitry or system subsystem of value or necessary need for voltage increase or decrease. So thus the ultracapacitor is going to have the Pelletarian cooler effect. Therefore, it have thermal resistance, using the pyroelectricity to cool the area of fraction within the coil, within the turns of the foil. Thus, I'm also using in this measure the shutters. I cut a piece, only a piece of these shutters. Some are using these shutters along with servos to close the front door and to thrust vectoring. Now the back, I'm going to cut 1/2 of a circular wafer like this, 1/2, so that I could use when I do get my motors to close 1/2 of this. This will correspond along with the servo. So thus the wafer will be of the metal wafer localized over there over this system, and it be cut in 2 parts. However, they have a circular that both divided creates 1/2 and 1/2 of the motor housing. Thus, I mean, exposes the motor housing because of the circular hole that is applied into the metal. Thus, when I close it and open it, I could allow air to be closed from vacuuming. This is backwards, so I don't have it forward. Now, this assemblation right here is how the transformation of the thigh may correspond in drones when doing the Ironman Mark 42. Thus, these are connected in a chain, like in scissorines, as the drawer and slide. This is the thigh, this is the calf, that is the foot. They are connected together on a drawer, either a drawer slider or a scissorine, separate from one another on both sides, being controlled by a servo that controls one side and a servo each coupled to the housing of the fan. Thus, the fan should be able to, by the servo configuration, the three formula, believe it's the three formula servo configuration, to allow the fan to turn horizontally and also to turn vertically due to the servo bracket arm that is coupled to the motor, like this, allowing it to rise up and allowing it to fold down. So this drone will have four different blades. Obviously, you don't see the other part of the plastic is localizing my lock. That way I have to get it to achieve it and apply the other sets like this, so that it can configure the measure of the account and according to my biometrics, measuring according to my biometrics. So therefore, I'm also going to be using the the electrical energy. I'm going to be using a scramjet type um, series of units. So even though I'm going to vacuum in, I'm going to leave an open slot. So when I close the shutter, so I cannot vacuum air in, it's going to have a nozzle there, which connected to 4 different micro piston kits, which is DC motor piston kits. They have 500 psi, so I'm going to be using 4 of them for each motor set for one part of the thigh, one part of the thigh, one part of the sole. Each one of these will receive all together. This is just one leg. So these will be connected in a chain. So they fold over to like one door, making 4 different parts to an entire calf exterior or thigh exterior, or circumferencing the exterior. So as far as the foot, the same. Now, but you only need 2. This is the hip thigh. I'm also going to put a rotary there too, bracket brace drum for the rotary. So that also will enable it to fly in the air. Remember that the rotor rotations are diverse drive. Both drives the same direction towards one another and drives the airflow into the center to cause a vortex. So all 4 of them should drive the air, the oxygen and neutron molecules, to create like a vortex or a swirl, like a tornado within the center of the unit of the armor. Now, um, now, no, the scramjet, I'm going to be taking I'm going to be using a cylinder sampler bomb, and I'm going to be cutting it too, and I'm going to add a cubic cylindrical tube inside of it, a metalloid, and I'm going to be cutting holes in that metalloid tube and add blades on coupled onto it. I'm also going to be putting two ball bearings at the end that is small enough to fit in the shaft area of the pneumatic gas sampler. Thus, the pneumatic gas sampler having two ends for interest for inputs of air or gas and outputs to exert the combustible gas, which is a cylinder sampler bomb. Thus, I'm going to put ball bearings so that it allow it to turn like a sprocket within the shaft. Though the cylindrical rod, is going to be connected to the ball bearings that is between the housing of the pneumatic sampler gas nozzle, and that will, I'm gonna also couple a gear to it so that I can use alongside it a high-speed motor bearing a gear to torque the step down gear that is coupled to the cylindrical tube that it has freedom of rotation within the shaft of the cylinder sampler bomb. I'm going to be cutting it to and then binding it together after I apply the the rotaries in there, so that the vacuum from one end sucks and causes sporadic combustion, to whereas the gas or air fills into the cylinder. It has really nowhere to go but to try to find a way to exert. Now, the nozzle doesn't have constant freedom because the holes are localized more in the center. So what happens is the air would have to find a way to escape. So we go through the rotating tube that is rotating the blades, the turbine blades, the vacuum blades, compression blades, and these blades will these are the combustible sampler will the air will have to flow into the cylindrical tube and escape from there, which increases more velocity and self-inductance and how can I say, expansion. Thus, I'm also going to add quartz, a chainmail link around the cylinder sampler bomb. This chain bell link that should be separate from the cylinder sampler bomb with I'm going to be using a ceramic powder and place it on the surfaces. And then I'm going to be using a chainmail that has nothing but ring links to where they are not connected permanently. They have loose ends to where individual rings are linking together. And these are very micro. It is necessary for me to apply it to this alongside to wrap the cylinder area of the housing with that chainmail as of to turn it one time so it could cover the exterior of this cylinder bomb. Then I'm going to be adding pyro crystals, quartz crystal rings, and apply it over the cylinder sampler bomb. And on top of the pyro crystal rings, I'm going to use nickel neodymium. The pyro rings are semiconductors, reacts as a semiconductor, and the nickel neodymium reacts as a superconductor. And I'm going to be using 52 Newton nickel neodymium rings. However, I'm also going, in addition to that, on top of it, as a stair or as a stack, I'm going to be using ceramic pyroelectric buzzers. These ceramic pyroelectric buzzer rings will fit around the exterior of the nickel neodymium. Thus, driven by an acoustic driver, bending deformation and causes the pyroelectricity, creating the Pellettier effect through the semiconductor and superconductor causing thermoelectric refrigeration, or the Seebeck effect. So that, not only in addition, but in addition to the acoustic force that is causing pyroelectricity, creating electrical energy, it's also going to be, and the rings are to ground the pyro quartz crystal electrical energy. Now, that circumference around the cylindrical shaft exterior. So, the cylindrical cylinder sampler bomb exterior. So, anyway, in addition to that, not only does it cause the pyroelectricity, because it causes also the matter within the shaft to 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 escape from the walls through intense radiation. Intense radiation pressure applies a force against the matter within the shaft and causes the matter to move away from the foundation of it, which reduces the chances of the cylinder sampler bomb of detonation or as of exploding of its exterior. It causes the pressure to squeeze the pressure into the center of the unit. The forces, the intense radiation pressure of ultrasound waves, and the intense vibrations and radiation pressure, pushing matter into the center of it in motion moving forward. However, in addition to that, the rotary is going to be torqued by a high-speed motor, which is going to suck the vacuum in. And it's also going to displace it and dispatch the air the molecules that are being vacuumed in through a subsystem of the heat exchanger and cool exchanger. Thus, it first must go through the cool exchanger and then goes through the heat exchanger to exchange the heat into to accommodate it for fluids. I'm going to be trying to develop fluids as far as fuel source as hydrogen within that system by collecting molecules, liquid molecules, and then transforming that molecules into hydrolysis, which is going to be localized on the device. And that electrolysis will create the hydrogen necessary that is needed. There is no need for me to use sodium. I can still create hydrogen out of water using the electrical electron arcs, like tungsten rods, which is used for like electrodes, which are used in welding. So that and into a shaft, creating hydrogen, receiving electric voltage. That will also generate the fuel source I need, which is not for gas, but for power to power my systems of motors and my systems of rotaries. The air compression should go into the cylinder bomb and exert. I can have one side of the body, one side of the upper body exert out of the arms, or I mean the hands. And another side, as far as the long side of the lower part of the body, to exert out the foot. Each individually, separately by itself. Where the vacuum energy that is going to be compressed in from 17 kilogram thrust motors, which are dualed. However, I'm also going to have dual motors on top of one another, where these will be exchanged. And the blades will also be stepped up to a higher gauge. But the housing drum of the fan bracket I will keep. Now, I'm using servos to drive two on top of one another, so that the thrust vectoring will also thrust in a vertical position, not only horizontal. So, in each part of the segment, which will be double, so 17 kilograms double twice, it should be over 64 or 62 rotaries, 62 17 kilogram T motors, P80 type. So I'm gonna cut this short right now. I have to go, and I'll talk to you later.